When we solve for a system of equations, step one is to make sure you have one of the variables isolated. In this case, the y is already isolated. And now you can isolate the x or the y, but this one, they're giving us the y. And the reason we need that isolated is because we're going to substitute what y is equal to into the second equation. So I'm going to rewrite the equation, and instead of x minus y, I'm going to put what y is equal to, which is negative 3x plus 2. So you see, I took that second equation and I rewrote it, and the only thing I changed was y. And I used what I know y is equal to from the first equation. Now we're going to solve it just as we would with any multi-step equation. Remember, that negative is actually a negative 1. So I'm going to start by distributing that negative 1. Negative 1 times negative 3x is positive 3x. Negative 1 times positive 2 is negative 2. I can combine like terms. Remember, we still have that 1 there. So 1x plus 3x is 4x. I'm trying to isolate the x because that's what I'm looking for. So to get me closer, I'm going to use my additive inverse, add 2 to both sides, because negative 2 and positive 2 is 0. This is getting me closer. 2 plus 2 is 4. Next, I need to use my multiplicative inverse, divide both sides by 4. That cancels out, and we get x equals 1. Now, we're only halfway there, though, because remember, a solution to a system of equations is a coordinate. If we were to graph these two lines, we're looking for the point where they intersect, because that's the solution. The solution is a coordinate. So now I need to substitute my x, so I think x is 1. We don't know yet. We're going to find out in a minute. So we're going to substitute that into one of the equations. At this point, it doesn't matter which equation you use. I'm going to use the first equation. Y is equal to negative 3x plus 2. This is where I'm going to substitute for x. I've already solved for x. It's 1. Now I'm solving for y. So negative 3 times 1 plus 2. This gives me negative 3 plus 2, which gives me negative 1. Now, I think I'm right. I'm pretty confident. You know, I followed my steps. I'm taking my time. This is probably like the 12th time I've started this video for a variety of reasons. But now I'm ready to do my check. I didn't mean to make a highlighter. So now we're ready to do the check. And the reason we do the check is to make sure that the coordinate is correct, because I might have made a mistake in that second part solving for y. So the only way to be sure is to substitute the solution, which we think the solution is 1, negative 1. We're getting ready to check. And I need to use the other equation. When I say the other, this is the equation I used to solve for y. To do the check, now I'm going to use the other equation. So I have x minus y equals 2. Remember, our variables are always, our coordinates are always written in the order of x and y. So now to substitute, instead of x we have 1 minus y, which is negative 1, equals 2. When you subtract a negative, that is the same as adding 1. 1 plus 1 is 2. This is my true statement. This tells me that my coordinates that I came up with are correct. So the solution to number 1 is 1, negative 1. In this next system of equation, you'll notice that neither one of these have an isolated variable. So if you remember in the foldable, it said step 1, isolate one of the variables. So we have to do that ourselves. Now, it doesn't matter which variable I isolate. I'm going to isolate the y, though. And the reason I'm choosing that one is because it's the only one that doesn't have a coefficient, which means I can isolate it in one step. Here's what I mean. I want to isolate the y, meaning I want to get it by itself. So to do that, I'm going to use my additive inverse. Additive inverse. I'm going to add 2x to both sides of the equation with the equal sign. That adds up to 0, which leaves me with my y, and look, it's already isolated. Now on the right side, a common mistake that I see is that people think, oh, I can just add that together and either get 4 or people will write 4x. That can't happen because these are not like terms. You can't add them together. All you can do is put them next to each other. Now, the y is isolated. I'm ready to do my system. So my original equation, or my first equation, is 3y plus 4x equals 16. My second equation now is y equals 2x plus 2. These are equivalent equations, right? I just moved it so the y is isolated. All right, but the reason I did that is because now I'm going to substitute for y. Here's what that looks like. Instead of 3 times y, I have 3 times 2x plus 2 plus 4x equals 16. See, take a moment, notice the only thing that changed is the y. I just substituted the 2x plus 2 because I know that that's equal. They're the same value, so that allows me to substitute. All right, back to our multi-step equations. I need to distribute because there's parentheses there. 3 times 2x is 6x, and 3 times 2 is 6. I need to combine my like terms. I'm going to subtract 6 using my additive inverse. I'm going to divide by 10. That's my multiplicative inverse. And that gives me x equals 1. Now, I'm only halfway there. I need to find the value of y because we're looking for the coordinate. It doesn't matter which equation I use, actually. I could use, I'm trying to get my highlighter. I could use this equation if I wanted. I could use this equation if I wanted. I could even use that equation if I wanted. And I think that last one, I think that's easiest to work with. Why am I in green? I don't even know. Y equals 2x plus 2. Okay, we solved for x and said it was 1, so that's what I need to substitute. That's going to allow me to figure out what y is. 2 times 1 is 2, and 2 plus 2 is 4. So now I think I have my answer. I think my answer is going to be 1, 4. But we need to check. So here comes the check. Remember, I need to use the equation that I didn't already use to find y. So I used the second equation to find y. So for my check, I need to use the first equation. Remember, I already have my solution here. This is what I'm checking. So instead of x, I'm using 1. Instead of y, I'm using 4. So 3 times 4, because that's the y, plus 4 times 1, which is our x. And let's see if this works. 3 times 4 is 12, 4 times 1 is 4, and 12 plus 4 is 16. And because they're equal, it tells me it's a true statement, which means our solution is correct. In this system, we're back to kind of an easy problem where they've already isolated one of the variables for us. So I'm going to take this x minus 4, and I'm going to substitute it for y. So I'm going to rewrite my second equation, 2x plus y, but instead of y, I'm going to substitute, I almost forgot what I was doing, plus x minus 4 equals 5. This is my y. I just substituted it for what I already know is equal to y. And I do that because now my whole equation only contains x's. I can solve for one variable at a time. I can't solve for 2 at the same time. All right, from here, and you know what? I don't even really need these parentheses because there's no negatives here to deal with. So if you need them, you can put them there, but there's nothing to distribute, so we don't really need them. I'm going to go right into combining my like terms. Remember, there's a 1 there. So 2 plus 1 is 3. That's where that came from. Minus 4 is 5. And use my additive inverse. Those cancel out, so I have 3x is 9. Use the multiplicative inverse, divide by 3. We get x is 3. But we're only halfway there. Let's come back up here. We're going to figure out what y is. I'm going to use the first equation. That one looks a little easier for me. So the original equation is y equals x minus 4. We're going to substitute 3 for x. So y equals 3 minus 4. And 3 minus 4 is negative 1. So I think my solution is going to be 3, negative 1. Let's find out by doing the check. Check. So remember, to do the check, you want to use the equation that you didn't already use to find your other variable. I used the first equation to find my y, so to do my check, I need to use the second one. All right, my y is 3, so I have 2 times 3 plus y. Instead of y, we have negative 1. So let's see, 2 times 3 is 6. And I can say 6 minus 1 is 5, and yeah, that's true. So we did it. We have the correct solution. All right, one more to go. So here we have another example of a system of equations where we do not have an isolated variable. I noticed that in the first equation, the x doesn't have a coefficient, and the same thing for the second equation, the y does not have a coefficient. So either one is going to be easy to work with. I'm going to choose to isolate, oops, what am I doing? I'm going to choose to isolate the x in that first equation. I didn't have my highlighter on, that's all. So I'm going to use this equation, I'm going to isolate the x. How am I going to do that? Let's find out. So I have x plus 2y equals 2. I'm trying to isolate the x, so I'm going to use the additive inverse and subtract 2y from both sides. You see how the x is isolated now? Because 2y and negative 2y are opposites, they cancel out. They add up to 0. On the right-hand side, we cannot combine these because they are not like terms. So I have to write them next to each other. All right, now I'm ready to do my system. My first equation is, right here, x equals negative 2y plus 2. And then I have the second equation, 2x plus y is 7. We're going to substitute. This is the same as x, so I'm going to substitute it for x. Let's see what that looks like. Instead of 2 times x, I have 2 times negative 2y plus 2 plus y equals 7. The only thing that changed was the x value. I changed it, or I substituted it with negative 2y plus 2. Because now I can solve my multi-step equation and find the value of y. All right, so let's do our distribution. The distributive property allows me to do this. So 2 times negative 2y is negative 4y, and 2 times 2 is 4. Again, I'm going to combine my like terms. Negative 4y plus y is negative 3y. Additive inverse, subtract 4 from both sides. Multiplicative inverse, divide by negative 3. And we get y equals negative 1. Again, halfway there. We have to figure out x. Now, it doesn't matter which equation I use. I'm going to use the one that I isolated. So I'm going to use x equals negative 2y plus 2. I think y is negative 1, so that's what I'm going to substitute here. So I have x equals negative 2 times negative 1 plus 2. Negative 2 times negative 1 is positive 2. 2 plus 2 is 4. How do I know if I'm right? That's right, we have to do the check. And which equation am I going to use? I'm going to use the one that I didn't already use. So I already used the first equation, so for my check, I need to use the second equation. So the second equation is 2x plus y equals 7. Now, I think my solution is 4, negative 1. Now, be careful, because for me anyway, I get in the habit of solving for x first. So I might have been inclined to make my solution negative 1, 4, done it backwards. So just, double check on yourself that you're not mixing that up. Little professional tip there. X is 4, because remember our coordinates are always written as x and then y. So as I'm substituting, 2 times x, that's 4, plus y, which is negative 1. 2 times 4 is 8, minus 1 is 7. So we did it correctly. Correct answer. All right, I just went through 4 examples of solving systems of equations by substitution. You've seen 2 where the isolated variable was given to you, and then 2 where you had to do it yourself. So I hope this video was helpful. If you have any questions, you know where to find me.